Welcome to my class. In this particular video lecture, we will talk about cache memory. Types of computer memory. There are different parts of primary storage. There are four main parts of primary memory. The first part is random access memory, that is RAM. Second part is read-only memory, that is ROM. The third part is cache memory, and the fourth part is registers. In this particular video lecture, we will focus on cache memory. Cache memory is used to store operating instructions and data that are likely to be needed next by the processor or instructions that are frequently processed. It means all those instructions or data which is urgently required by the processor. They are stored in cache memory. Cache is a block of high-speed memory where data is copied when it is retrieved from the RAM. This storage of key instruction enables improvement in the performance of the processor. Instead of fetching information from RAM, CPU stores information in cache. All those instructions which are needed by the processor or which are frequently processed by the processor, they are stored in cache. Intel processors have level 1, L1 and level 2, L2 caches. These are two groups of extremely fast memory chips that allow the computer to operate faster. The first one is internal cache. L1 is built into the CPU, therefore refers to internal cache. Second is external cache. L2 resides on the motherboard, therefore refers to external cache. Since L2 resides on the motherboard in between RAM and CPU, it improves performance by reducing the average memory access time. L2 cache is also called SRAM. Both L1 and L2 store data recently used by the CPU. When the CPU needs data, it first checks the fastest source, that is L1. If data is not there, the CPU checks the next fastest source, that is L2. If data still cannot be found, then a time-consuming search of slow RAM is required. Let us look into the general functioning and then we will move on to cache memory. This is motherboard, and on the motherboard we have a ROM. ROM is read-only memory, which is permanent in nature. Hard disk, RAM. RAM is temporary memory. Then we have CPU. Operating system is on the hard disk. The moment we switch on the computer, instructions from the ROM comes out and they look into the hard disk. Those instructions try to find out the operating system. Instructions copy the operating system from hard disk and takes it to RAM. Now in the RAM, operating system takes over the control of all the operations of the computer. The job of ROM comes to an end and the total control of the computer is taken over by operating system. Operating system sends some of its files to CPU. CPU processes those files and returns it back to RAM. RAM shows the result on monitor. If some files are required to be stored on the hard disk, then they will be stored on the hard disk. This is the model of general functioning of the computer. Now we shall focus on cache. Without knowing this particular general functioning, it was difficult to understand the functioning of cache. Cache memory. The explanation of cache memory is divided into 5 different phases. Phase 1. On the motherboard we have ROM, which is permanent memory. Then we have hard disk, RAM. RAM is temporary memory. Then we have CPU. Operating system on the hard disk. Instructions from the RAM comes out, looks for operating system, copies the operating system and takes it to RAM. Operating system takes over the control of complete computer. It sends some of the files to CPU. CPU processes those files and returns it back to RAM. RAM shows the result on monitor. This is what we learned in the general functioning. Now we are going to introduce the cache memory. Since there is a distance between CPU and RAM, what we did, we introduced one more memory in between CPU and RAM, and that memory is named as cache memory. It is termed as L1 or level 1. Now this memory is on the motherboard, but it is nearer to CPU. RAM is away from CPU. CPU does the job of processing. While processing, it stores some of the instructions which are frequently required by it. It stores it on the cache memory. And whenever CPU needs those instructions, it takes it back from the cache memory. The distance between cache and CPU is less than the distance between CPU and RAM. So it improves the functioning of the computer. The processor is able to process things very quickly. This was the initial stage when on the motherboard cache memory, that is level 1, was installed. This happened in phase 1. In case instructions are not found in the cache memory, then CPU looks into RAM memory and CPU gets those instructions from the RAM. First it will look into cache memory. If required instructions are not present in cache memory, it will look into the RAM. This is phase 1. In phase 2, we know that cache memory is in between CPU and RAM. In phase 2, some technological advancement took place and we shifted this cache memory within the CPU. Now this becomes internal cache. CPU will store some of its instructions which are frequently processed by it in the cache memory. It will not send it to RAM, rather it will store it in the cache memory. So whenever it needs it, it will look for those instructions within itself, that is in cache memory, and it will retrieve those instructions. If these instructions are not there, then CPU will look into RAM and fetch the required instruction from RAM. This happened in the first phase, that we shifted cache memory from the motherboard to CPU. Now CPU has got inbuilt cache memory. We move on to the phase 3. In the phase 3, we know that CPU has L1 cache memory within itself. In phase 3, on the motherboard, we introduced one more cache memory and we named it as L2. Now look, how does it function? CPU stores some of the frequently required instruction in L1 and some of the frequently required instruction in L2. CPU is processing. In case it needs some instruction, first it will look into L1. If the required instructions are there, it will fetch it and it will start processing. If the required instructions are not in the L1, it will search into L2 and it will fetch instruction from level 2. If instructions or data is not in L2, then CPU will look into temporary memory, that is RAM. It will fetch the required information, data or instruction from RAM. This happened in the phase 3, that L2 was introduced on the motherboard. L1 is within the CPU and L2 was installed on the motherboard. Let's move on to phase 4. With the more technological advancement, it brought certain changes. We have learned up to this particular point that L2 is installed on the motherboard. As when technological advancement took place, we shifted this cache memory from the motherboard to CPU. Now CPU has got two cache memories. One is L1 and the second is L2. How it will function? CPU will store frequently required instruction first in L1. If it is there, it will fetch it. If it is not there, the CPU will look into L2, which is within itself. If those instructions are within itself, it will fetch it and start processing. If required instructions are not there, then CPU will look into the temporary memory, that is RAM, and it will fetch the required instructions. This was happening in phase 4. This is phase 5. Some more technological advancement took place in phase 5. Now we know that there are two types of memories which is within CPU, and that is cache memory level 1 and cache memory level 2, or we can call it L1 and L2. Now again we introduce one more memory on the motherboard, and that memory was cache memory level 3. So at present the cache memory level 3 is on the motherboard. L1 and L2 are now inbuilt into the CPU. How does it function? CPU will look into the instruction first in L1 and it will fetch the instruction. If it is not there, CPU will look into L2. It will fetch the required instructions. If it is not there, CPU will look into L3, which is in between RAM and CPU. If the required instructions are on the L3, then it will fetch those instructions from level 3. If within the cache memory L3 those instructions are not there, now the CPU will look into temporary memory, that is RAM. It will fetch the required data or instruction from RAM and then it will start processing. Now look one thing, RAM is away from CPU, cache memory L3 is in between. It means to fetch information from L3, CPU will take less time. If it takes less time, then the CPU's performance can be improved. With the result, overall performance of the computer upgrades. This is the basic purpose of introducing L1, L2 and L3. At present we find that L1 and L2, they are built into the CPU, and there is one more memory installed on the motherboard, that is L3. Now there are three caches, level 1 L1, level 2 L2 and level 3 L3. Internal cache. L1 and L2 are built into the CPU, therefore refer to internal cache. External cache. Cache L3 resides on the motherboard, therefore refers to external cache. These are the two groups of extremely fast memory chips that allow the computer to operate fast. Thank you very much.